2021, which is your year. Okay, so if you scroll down, look at this. All of look at this. All of the SPM trial papers for all different subjects. Everything is here. Yeah, everything is here. Okay, so for example, if we go to mathematics, so everything is here, right? So if you seriously, guys, for the subjects that you're taking, if you can finish all the if you can finish all the trial paper here, I think you will be more than ready lah. You will be very, very ready. And look at this, under mathematics, look at this. So many, I already counted, there are 18. So for example, you click in Selangor, see? Some states has even more than one past year papers. Right. So and all of them, they have jawapan for you. They have the answer scheme for you some more. Okay, all of these are all for free online. Okay, so please utilize the remaining 3 weeks, right? 3 to 4 weeks, I think, before your SPM, and finish them. Do all the trial papers here. Okay, more than enough lah. More than enough. So actually, 90% of the questions that I discuss in class with you guys, right, come from here. Of course, I cannot discuss every single question, right? There are 18 freaking papers here. Okay, so I pick lah. So you guys, please go ahead and do. Mathematics got so much. So I don't know lah. What English? You say, oh, English, English less. But you get the point. Okay. Very easy, just go Google and search SPM trial, SPM trial 2021, and that is the first link. Okay? All right, I think let's get started lah. This one is just a small sharing here. Let me close this. Okay, and then let's go back to our slides. Okay, for those who just came in, okay, please make sure all of these are ready. I wanted to actually, can I try again? Can you guys just help me click one more time? I just want to see who is here and who is not here. So for those who didn't tick, obviously it's not here, I think. Thanks, Jinghao. The rest, ayo, you come. Okay, I don't want to judge. I don't know what's happening. Maybe from your side you cannot click or whatever. I don't know. Yeah. Yeah, I start already lah. All right. So today, we are going to cover two topics. Two topics. So 2 hours, 2 topics. 1 hour, 1 topic. The first topic is graph of motion. For those who are interested to know the Malay name, okay. This one I know. Graph gerakan. This one Malay name lah. Okay. So 1 hour we'll go through this one. So actually 1 hour quite shortly. I think we'll only manage to do maybe 3 questions. Yeah, but it's okay. Okay. These 3 questions basically cover all you need to know already lah. So the idea about this intensive class is I try to choose the question that will cover as much as the knowledge that you need regarding that chapter. Okay. If you need more practice, that is the one that I just showed you, the SPM trial, right? Go online and do yourself. Answers are all in there. This is the second topic that I will cover, linear inequality. In Malay, it's called kesamaan linear. Okay, in Malay. Okay, so 1 hour for that as well. So, okay, let's get started. Okay, so let me give you a very brief, actually not brief, but a summarized overview, okay, of the entire chapter. Basically, all you need to know about the chapter is right here on this single slide, okay? So let's get started. For SPM, you only need to know 2 types of motion graph. One is the distance time graph. What in Malay? Graph jarak masa. Jarak masa lah. Okay, graph jarak masa. Okay, let me write for you also lah. Okay, and then the second type of graph is speed time graph lah. Speed is laju, right? How fast something is moving. So graph laju masa. Good lah. I'm practicing my Malay also lah. Okay, so let's start with distance time graph first, okay? So obviously, if it's a graph, you must have x-axis and y-axis law, no need to say one. Okay, but normally we will label this as x and y, right? Okay, but this one is distance time. So we wouldn't label it as x and y anymore. For x-axis, we'll label as, I hope you know, time. The symbol of time is t. So normally they will put a bracket at the side to indicate the unit of time. Now, time, you can take on 3 units, obviously, hours in terms of hour, minutes or seconds. For distance time graph, normally, actually, okay, I shouldn't say normally because I did see questions that use hour, minute also got, seconds also got. So depend. Okay, so let's just say for this, I'm just gonna write this as seconds. Okay. All right, and then obviously this one here, this already says distance. So distance. What do you call it? Symbol is d. Okay. The unit for distance again could be meter or kilometer. Normally is in terms of meter or kilometer. If the time is in seconds, then usually meter. Meter will usually go with seconds. If it's kilometer, normally it will go with hours. Okay, minute, a bit rare to see lah. Okay, so now once we have the axis, we can start. Let's say the graph looks like this. Okay, you know what? I'm gonna draw this. Okay, a straight line graph starting from the origin. Okay, starting from origin, and I draw a straight line like this in my graph, in my distance time graph. So what does this mean? Okay, guys, think a bit. Okay, think a bit. What does this mean? Now, again, there's a reason I asked you to bring a paper, whatever. Okay, with you, right? I know eventually I'll let you take picture, but if you want to, you can just, as you listen, you draw on your paper also, like follow me lah, right? So as you draw, then there's another way you keep yourself awake. I know it's quite late, 8 o'clock. Okay, I can still keep my energy one. Okay, I don't know about you guys, but yeah, as you listen to class, you write at the same time. That is another way to keep yourself awake. The notes is not for me, it's for you. Okay. So anyways, stop babbling. So if I have a straight line graph for distance time graph, looking at this, that means the distance. So let's just say there's a person here. Okay, one person. Whatever lah. Okay lah, person here. Okay, this person started from a point, we call it origin. Where it starts, we call it origin. So obviously, if the distance, look at this, the distance is increasing. That means this guy must be moving away from the origin. That is why the distance become bigger and bigger. That's why the distance become increasing and increasing. That means further and further away from the origin. So the first portion of the graph, this one is actually, okay, I write here, D is increases. Okay, that means the object is moving away from the origin. Okay, this one is one. Another one, we can see, you see this part of the graph, it is a straight line. That means, right, let's just say every 1 second it move, wow, too fast. 1 second move 5 meters. Too fast already. This one crazy. 1 second, if I move 5 meters, that means within 1 second, this guy can move 5 meters. Wow, this one is, I don't know what kind of species is that. So too fast already. Maybe 1 second, 0.5 meter. Okay? Because it's a straight line, right? That means if I increase to the second, okay, the increment in terms of distance should be the same. That means, I hope you can tell me, after 2 seconds, the distance should be 1 meter. 1 meter, correct. Because half a meter in 1 second, so 2 seconds, 1 meter. So of course, the 3rd second, right, it will be at 1.5 meter away from the original. So if somebody is moving in this manner, right, the increment of the distance is consistent. That means, you think logically, this guy, it must be moving at a constant speed. That means is moving at a very consistent rate. Like it's like not suddenly, wow, suddenly run very fast, suddenly run very slow. If it suddenly run very fast, suddenly walk very slow, right, then the graph wouldn't be straight really. It would be a curvy. It would probably be something like this or something like this. Don't worry. In maths, you are not required to know this. However, hey, for those who are taking physics, I think you should know about this. I think you need to know this, right? In physics, okay? But in maths, no lah. They will ask you about curvy graphs. Okay, so that's good. So anyways, let me write here. It's moving away from origin at a constant speed. That means it's the movement is a very consistent. It's not suddenly faster, suddenly slower. No, very consistent movement. Okay. For those who are studying this in Malay, okay, I did do some studying. Okay. The Malay word for this. Let me write this down. Just in case any one of you would like to know. Okay. You see, purposely, I don't know if any of you realize or not, but today I changed my app. Okay, today I changed to this app, OneNote. Can do a lot more things. Let me delete this. Okay, so I write in green. Okay, what Malay version for constant speed, if they ever ask you to describe, it's called laju seragam. Okay, this is the Malay term lah. Okay, that's it. So every time you see a increasing straight line in a distance time graph, think logically. Oh, increasing straight line going upwards, distance increasing. Distance increasing mean what? Moving away from origin. And then if it's a straight line, that means it's moving away from origin at a consistent rate, at a constant speed. Okay, learn to use these keywords lah, if ever they ask you to explain. Okay, now let's move on to the second portion of the graph. Okay, so let's say lah, after this guy move until a certain time, right? Then, wow, why so smart one this? how they know I want to how they know I want to draw a interesting. I did actually want to draw a straight line. So I'm so smart on this app. Okay, so anyways, okay, until here. Okay, so let's just say the second portion of the graph is a straight line. Okay, well, this one is a straight line, but this one is, we call it a horizontal line. So think about what does it mean. Okay, when the distance is showing you, distance line is showing you a horizontal line, that means maybe from time, let's just make this easy, time from 4 seconds all the way to, let's just say 8 seconds. From time 4 seconds to 8 seconds, right? Looks like the distance doesn't change. Distance not changing. Okay, so if distance is not changing, think logically. If the guy initially moving, right? Okay, moving away. This one is the origin, right? Moving away. Suddenly at the 4th second, right? The guy reach here, and then the distance doesn't change for the subsequent 4 seconds. That means this guy must be. This is the word we use to describe stationary. In other words, it's not moving lah. Right? If the distance doesn't change, that means the guy must be staying at the same place. Okay, so we use this English. We use the word stationary to describe something that's not moving. I think in Malay you just need to say tidak bergerak. Just like that. It's good enough lah. Tidak bergerak. What about halt lah? Good question, Julian. I wouldn't use that word. Because me being mathematic teacher, I also teach physics also. Okay, I'm very particular with the keywords. When you say halt, that means it's like you walk suddenly like that. Halt is about at the split second the guy stopped at that particular second, right? Then after the halting we don't know what the guy is doing. So in maths and also in physics, for those who are also taking physics, right? If you want to describe this kind of motion, go with the word stationary. Or if you really cannot remember the word stationary, just say not moving. Better. Okay, this not moving stationary, very clear, no ambiguity there. Okay, tidak bergerak. Yeah, keep the question coming, guys. I love answering questions, please. The more question I get, the more excited I will get. If not, you know, also at night already, if I keep talking, it's like I also talking to myself. Nobody talk with me. Okay. Anyways, continue. Okay. I think some of you might have already guessed, right? What I want to do next. Okay. Go. Go down lah. Okay. Go down. So when we say go down, it means. Come. Let me connect this. Come on. Okay. Nice. Okay. Is it? So this one, what does it mean? Okay, so the guy obviously not moving for 4 seconds. Okay, so this guy, okay, not moving for what? 4, 5, 6, 7, 8 seconds. Okay, then from 8 seconds onwards, the distance is decreasing. So decreasing means what? Must be because the guy, right? Decreasing distance means it must be because it's going back towards the normal. So the distance of this guy from the origin, right? Did I say normal? I should say origin. Yeah. The guy must be going back to the origin. That's why the distance of that guy from the origin will be decreasing and decreasing and decreasing and decreasing until it reach here. Until it reach here where the distance became 0 again. That means when the distance becomes 0, that means it come back already. It come back. So let's just say this one, I don't know, let's say 10. This guy took 2 seconds to go back to the original position. That's what it means. Okay, so I write here, this one decreases. Okay, decreases. That means it's moving. Instead of moving, just now moving away from origin, right now you say moving towards lah. Towards. So learn to use these keywords. People who are doing physics, you will thank me also. Because you also use the same keywords for physics if they ask. Moving towards the origin. Okay, of course, straight line again. That means it's moving at a very consistent rate. So we say moving at a constant speed. Done. Okay, for maths, in terms of distance time graph, these are the only three shapes lah. Okay, 3 types of graph lah. You need to know. They won't give you curvy graph lah. But physics got lah. But maths don't have. Okay. 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 So this is all about distance time graph. Okay. Now let's move on. Okay. Don't worry lah. I will later let you take picture. Okay. Speed time graph. Okay, now you need to switch your mindset ready. We are talking about speed now. That means how fast the guy is moving already. Okay, we are not talking about distance already. So same thing. If you have graph, x and y axis for sure come out first. Let me put it here. Okay. So same thing, same time. Put it at the x-axis, time. Let me just put it at seconds lah. Okay, easier. Hours also can lah. Depends on the question Speed. Okay, the symbol for speed usually they use v lah. Okay, but don't worry about it. I don't have to memorize this. But the unit you have to know. Now, speed is how fast the distance is increasing or how fast the distance is decreasing. So, meter per second. Okay, you should know lah. This one, meter per second or kilometer per hour. Okay, 2 types lah. Normally, if it's, that's why I told you guys, normally if it's a seconds, then it will match with meter. If it's kilometer, normally it will match with hour, kilometer per hour. So for those who are more observant, right, I'm sure all of you sit in the your parents' car. When your parents are driving, right, you for sure will see the speedometer in their car, right? Their car is usually in kilometer per hour. The cars never vehicles, we very seldom use meter per second. We always use kilometer per hour. Okay, just a little bit of knowledge. But anyways, same. Let's draw the graph now. So let me draw. Actually, it's the same shape. It's the same shape, but although the shape is the same, how come it become like that? Wait, let me try again. although it is the same shape compared to the distance time graph, but because the axis is different. Later I show you what I mean. Okay, nice. Okay, so you see, this one, the shape is the same, right? A straight line going upwards. The other one, this one also straight line going upwards. But they mean different thing. Why? Because the y-axis is different already. Just now, when the graph is increasing, it is the distance that is increasing. That means the guy is moving further and further away from the origin. But this one here, it is no longer distance increasing. It is the speed that is increasing. Let me write how. Let me write here. Actually, I can try this smaller one, right? Speed. Easier to write. Okay, the speed is increases. So you think logically. Let's just say you are a person, okay? And then, okay, you start at a particular place, right? Your speed is increasing. That means you are most probably, maybe you stop and then you start to walk slow, and then you start to increase your speed. That means you start to walk faster and faster, then start to run. So increasing speed, we call this acceleration. Accelerates in English. Okay, accelerate means it's like think of a car. You are stepping the pedal of the car slowly, become faster, like that. That is called increasing. So this is what the graph represents. Let me stop until here. Okay, let me write down the Malay version for this acceleration. Pecutan. Okay, just for your reference lah. Okay, so looks like this guy is like slowly increase, faster. And then if I do this, oh my god, that is so not straight. Okay. Okay. Oh, come on. Okay, let me draw the line. Hey, it doesn't. Sorry, guys. Give me a minute. This one, this thing doesn't want to snap into place. Okay, you know what? I gave up. I'm just gonna draw it myself. Okay, I know it's not gonna be straight, but you guys understand what I'm drawing, lah. Okay, until here. Okay, a consistent. Okay, so looks like, right? The speed, okay, not distance, speed, now became consistent. That means, right, looks like this guy, okay, suddenly at the beginning very slow, then faster. Let's just say it increased the speed until 10 meters per second, and then you see doesn't change. So this one, speed doesn't change. Okay, speed, no change. That means this is actually telling us that, oh, this guy is still moving, but it is not changing the speed. Constant speed. I hope you guys can see this, which is basically the same as this part here. See, for distance time graph, when it's increasing on a straight line, it's moving away from origin at a constant speed. So this motion is actually the same, but represents slightly differently in the speed time graph. These two it's like they are moving in the same manner, but because it's different graph, it's being drawn differently. Okay, so same lah. This one laju seragam, no need to write already. I write on the other graph already. So the last one. Wait. Okay lah, straight line, okay, straight line. Yeah, so obviously this one, the speed decreases. Okay, so speed decreases, that means the guy, let's just say, okay, this guy moving at 10 meters per second, run 10 meters per second until here, tired already. Start to slow down the speed, until it reaches this point where the speed becomes 0. Now think, what does it mean if someone's speed is 0? What does it mean if someone's speed is 0? I hope you can tell me. When speed is 0, that means the guy is not moving, stationary. There. Okay. So you can see that some motions are being repeated in speed time graph, repeated in both speed time graph and distance time graph, but the representation of the graph is different. Okay. But honestly, do you need to memorize this? I don't think so. If you really you understand the graph, what the graph is trying to tell you, no need to memorize. Okay. So speed decreases. In English, we call this decelerate. So this one is like so accelerate. Just now I said this one here accelerates. I said this one is like what you step on the pedal, so it's like you step on the car pedal. Okay, and then until here, and then you don't step the pedal further. You just keep the pedal at the same rate, move pedal, and then you release the pedal and you start to apply the brake. Apply a brake, stop, like that. Okay. So decelerates in Malay. I'm just gonna write this down here for your reference for some of you. Nia pecutan. Oh my god, this brings back all the memories. Like what? I cannot tell you how many years ago because then you can guess my age. But long time ago. Okay, so that's it. Okay, so let me zoom out to give you a big picture. See? Okay, this is your big picture. Okay, same shape of the graph, but just changing the axis, it means different thing already. Okay, yeah, let me just summarize very quickly lah. Whenever if the question, later you will see one question, right, they will ask you to describe motion, or in Malay they will ask you to describe gerakan. So they will, okay, they give you a certain graph and they say, okay, describe the motion of this vehicle, like how is this vehicle moving, right? So if you want to describe motion, you have only 4 options from what we have seen here. Only 4 options. The first option is the vehicle could be stationary, not moving. This is your first option. Okay. Second option is the vehicle or whatever, the guy, whatever, it could be moving, but it's moving at a constant speed. This is your second option. Okay. Speed. Okay. Third option, obviously, you are moving, but you are increasing the speed at the same time. So it's like you move, but you go faster, like that. So accelerates. That's your third option. And then lastly, decelerates. That's it. So this 4 is like all the 4 motions that came out in both of these graphs lah. Okay, so whenever they ask for description, you just need to describe these 4 only. Just choose from these 4 and then just use these keywords to describe. Nothing much really. Okay, so next when they give you distance time graph and speed time graph, right, very, very commonly they will ask you to find, for example, in the distance time graph, they for sure one, almost 90%, I can tell. They will ask you from the distance time graph to find speed. They will ask you how to find speed from distance time graph. Now, I write here, distance, okay, I just write distance, but you understand this distance time graph, right? From a distance time graph, how do you find speed? You find the gradient. That is why I purposely do straight line before this chapter. M, gradient of the distance time graph, will give you the speed. Later, when I do the question, you will be able to see lah. Okay? Then in a speed time graph, if they ever give you a speed time graph, they could ask you 2 things. One is they will ask you, okay, find the acceleration. They give you speed time graph, they ask you to find acceleration. So from speed, how do you want to find acceleration? You also find gradient. Also M. Okay? Again, later we will do a question about that. So this one is just, I purposely put here, speed. Another way to describe speed is a rate of change of distance. Okay, that's why I put this speed at the bottom of distance, right? Then acceleration is also known as the rate of change of speed. See, this one is an intensive class, so I wouldn't spend time to explain very detail why the definition is like this. Okay, so just take it as it is first for now because it's an intensive class. Okay, so okay, just now I said for speed time graph, first thing they can ask for acceleration. Okay, if they ask for acceleration in the speed time graph, you just find the gradient. They can also ask for distance. Speed time graph, you can also use speed time graph to find distance. How? I hope you can tell me. Area under the graph. All you need to find is, let's say, if I want, so this one is a speed time graph, right? This one is a speed time graph. If I find the total area under the graph, everything here, this value of area, it will straight away tell me how far or what is the distance the person or the vehicle have traveled. The area will tell me the distance. The slope, right, which is the gradient. Gradient, another, yesterday who said already? Is it yesterday or the day before? Somebody said the word slope. Yeah, slope or gradient or kecerunan. If you go and measure the kecerunan of the graph here, it will tell you the acceleration. Okay, that's it. So I think that's why I purposely put here. See, from distance, speed, acceleration, right? You go down, you find gradient. You want to go up, from speed, you want to go up to find distance, you find area under the graph. So actually, I know this is not in the syllabus, but for those who are observant, if you go up, let's say, okay, if you go to college or whatever, they give you acceleration time graph, and then they ask you to find speed, you do the same thing lah. Find area under graph. But don't worry lah, this one is extra. This one is extra. Okay, this is extra one. Okay, SPM only these three only. Okay, done. Okay, what else do we need to know? Formula given, the average speed is total distance divided by total time. Area, okay, I purposely put here area of trapezium, okay, because it's very common. Let's say I want to find the total distance traveled by this, using this speed time graph. So recall, if I give you speed time graph, I want you to find distance, go up, you find area. So if you want to find area of this graph, look at this shape of the graph. What shape is this? So this shape is actually known as trapezium. Okay. Reminder for some of you. Okay. Trapezium is a four-sided shape that has two parallel sides. That's it. So obviously this is a trapezium, right? Because this side and this side are parallel, ma. Okay. So the formula, if you want to find this area, right? Okay, how to find? This is the formula: half times sum of two parallel sides. That means, right, these two sides are parallel. This side, let me call this A lah. And then this side, let me call this B. Okay, sum of the two sides means A plus B. Okay? Okay, so that means you take half times these two A plus B, you add together, put here, okay, times the height. Height is here. This one, from here to here. This is the, let me change another color so it's clearer. Height here. This is the height. Height. Okay? So the formula for area of trapezium is very useful here, especially when they ask you to find the area under graph or speed time graph. Okay? Okay, that's it. This is all you need to know about graph of motion. Okay? This is the summary, the whole thing ready. Okay, so we're gonna use all the knowledge here and start doing the questions. Okay? Okay, I give you 5 seconds. If you need to snap a picture with your phone or whatever. 5, 4, 3, 2, 1. Okay, bye. Okay, let's start. Okay, there. Okay, read the question first, guys. Read the question first. Same, paper, calculator all come out, please. Don't just watch me do. Hello. Okay, come. This one, I forgot to write down which person. But this is definitely one of those trial paper question. Okay, so yes, I purposely put in the Malay version also lah. Okay, for those who are more familiar with Malay. But I am personally going to read English ones. Okay, can I? Distance time graph, good. Okay. Yep. For a journey of a bus and a car. Okay, so we have two vehicles here. One is the bus, one is the car. Okay, graph OPQR. That means they are talking about, do I have a highlight? Oh yeah, I do. Let's do a highlighter. Oh, let's go. PQR. This is car. Okay. Okay, so this is the motion of the car. Graph MQN, let me change another color. MQN is bus. Okay. Bing. Bing. Okay, let's go. Nice. So looks like, okay, anyway, let's analyze a little bit here. So looks like the bus, right, started at 40 kilometer. So, okay, you know what? Okay, let me do this lah. Okay, so let's just say this is the origin. Okay, so looks like, okay, and then the distance looks like it's gonna be at 40 kilometers. So the bus actually starts from here. Bus. Sorry, okay, I'm a math teacher, not an art teacher. So the bus start here at time 0, and then looks like it's decreasing. The distance is decreasing. Distance decreasing means this bus must be going this way, moving towards the origin. Okay, until here 25 minutes, and it reaches the origin. That means the bus took 25 minutes to reach back to the origin. This is what it means. Okay, so sometimes it's good also that you can visualize what's going on, okay, from the graph. Okay, this is bus. Okay, then what about the car? So the car looks like, okay, the car looks like it starts from origin, right? Green color car starts from origin. So this one is the car. Okay, so it starts move. Okay, move that, and then I hope you guys can tell me what happened. Okay, and then we continue to move again until where the bus is, but it took the total of 30 minutes lah. Okay, longer. So car looks like slower, or bus, maybe bus didn't rest, so bus faster. Okay, okay. So let's do the question together. Okay, calculate the value of t. Okay, calculate the value of t. So here, t is right here. Okay. Okay, so let you guys think a bit first. Process a bit first. How do we calculate t? They didn't give us any information like how long the car stop or whatever, right? They didn't give us. So how to calculate t? Okay, so I do lah. Quick, part A. Actually, can I zoom out a bit? Yeah, so that I can have more space. I hope you guys can see. If it's too small, guys, wait. Hey, if it's too small, you let me know. You let me know, because I can see this clearly. I don't know about you guys. Let me know in the chat box if it's too small. If not, I'm just gonna move on. Okay, A. For me, right, I wouldn't focus on the I wouldn't use the car motion really. I won't. I will actually use the bus motion, the yellow color one. Why? Because I know this is a straight line, right? M, Q to N, this is a straight line. So I know that if it's a straight line, that means the gradient of this straight line must be consistent. That means if I find the gradient from M to Q, gradient of M to Q must be the same, because straight line, that means the steepness must be the same. Gradient of must be the same, gradient of from Q to N. I will actually use this. So sometimes you need to smart a bit. This comes from experience, guys. That's why I ask you guys, do more trial papers. The trial papers. Okay, I will use this. Okay. Hey, guys. Of course, mathematics is about solving one single question from using different ways. Okay. If you have a different way from mine, it's all right. Okay. In fact, if you are willing, you can share it in the chat box. Okay. As long as our answers is the same, then your way can also work. Okay. For me, I thought of this way easier lah. Okay. So again, if you recall, let me just write it down here. The formula for gradient also given in the formula sheet: y2 minus y1 over x2 minus x1. Okay, so same old. This is our third lesson doing gradient already. So if I want to find the gradient of M to Q, let's write the coordinates down lah. M, the coordinates is 0 and 40. Q, the coordinate is T. Some student, ayo teacher, I don't know what T I don't know, but just write T first lah. Don't worry. Okay, T, and then Y coordinate is 20. Okay, right here. N, the coordinate is 25. X coordinate 25. Y coordinate 0. There, done. Okay, so let me call this up to you lah, up to you guys lah. This one X1, Y1. Okay, this one X2, Y2 lah. Up to you lah, doesn't matter lah. Okay, you want to do this one X2, Y2, this one X1, Y1 also can. Okay, so now you can sub already. Okay, substitute into the formula. My Y2 minus Y1, which is 20 minus 40. X2 minus X1, T minus 0. Okay, equals. All right, equals. What is the difference? Oh, Julian, it's exactly the same formula. Great question, guys. Y equals to mx plus c. Okay, come. Y equals to mx plus c. Let me be very clear here. You only do this whole thing when the question asks for equation. Equation of a straight line, of a line. If the question say find equation of a line, then you do this y equals to mx plus c. Okay, but are we finding the equation of the straight line? I don't think so, right? The question only asks us to find this value t only, they are not asking me to find the equation of this straight line, so I'm not even going to bother to do the whole thing. But I am going to use this. I'm going to find this gradient, this m, this m, this m, and this gradient. They all mean the same thing. Therefore, we can reuse the formula. Okay, Julian, I hope I answered your question. We don't need to do the whole package y equals to mx plus c. No need, because they are not asking for equation. Okay? Okay. Still don't understand? Don't worry. I'll just leave the guys, you can just leave your answer in the chat box. If I know time, I will go through the lesson first, and then after the lesson, I will come back to you, and don't worry. Okay? Okay, let me continue first. Next. So the other side, I said the gradient from M to Q must be the same as the gradient from Q to N, because it's straight line. Okay, the keturunan, the slope must be the same. So let's do the same thing for Q to N. So obviously here no longer is, oh my god, why did I erase all that? Let me go. Okay. No. Okay. Wait. Okay, nice. Okay. Okay, so now I want to focus on Q and N. So of course my X1, my X2, Y2, I'm just going to stick here, like lazy to erase. And this one I call this X1, Y1. Okay, so sub. Y2 minus Y1 for my case is 20 minus 0. X2 minus X1, T minus 25. Okay, that's it. So you see from here, right? I got an equation, one equation. Okay, of course I can simplify all this later. But I got one equation with only one unknown, which is t. Good. That means I will be able to solve for t from here already. Okay, so now let's simplify. 20 minus 40, negative 20 over t minus 0, t. Some student tell me t minus 0, 0. I smack the head. Okay, so 20 minus 0, 20. Okay, t minus 25 cannot do anything. So leave it there. Okay, so from here onwards, this one from here onwards nothing to do with graph of motion already. From here onwards, this is algebra skills already. Okay, so I'm not gonna spend any time talking about algebra here lah. We have to do faster. Okay, so I hope you can see this, right? Cross multiplication. Cross multiplication can only work if there's an equal sign in between. Please, some student they saw this. I give you another example lah. Okay, plus 20 over, let's just say you got another, another question where instead of equal, you hit plus. Some students say, oh, teacher, I can do this. Cross multiply and smack the head. Cannot, please. The cross multiplication only can work with equal sign. Again, because this is a intensive class, we don't have time to discuss why we can't do that. There is actually a reason. Okay. So you just take it first lah. Okay, so cross multiply. From here onwards algebra only. So what? negative 20t minus 25, then equals to 20 times t. So expand negative 20t plus what? 500 equals to 20t. Move the negative 20 to the other side, plus 20. So 40t equals to 500. So divide 40 to the other side. T equals to, I get the answer 12.5. Okay, 12.5. I don't just stop here because I want to write down the unit as well. Okay, look back to your graph. What is the unit that they use? Here, see? The time, they use the unit of minutes. That means this time that you are supposed to find obviously must be in terms of minutes. Okay? So I hope you get the answer. Okay, this one, guys, if you stuck, okay let's not say this lah. Okay, this one, experience. If you didn't know how to do this, that means you need to practice more on the paper, the trial paper, please. Okay. Okay, let me make this smaller. Yeah, this is the beauty of this app. Can move here and there to get space. Oh. Okay. Actually, wait, give me a minute. So I move here. Nice. Okay. This one. Okay. Then I have space for my part B. B. Okay, so let me actually see the moment I got T, right? Let me might as well just put the values into my graph already. Yeah, my T 12.5 I put here first already so I don't forget Okay, this one done. A done. Okay, next. The car stops at the petrol. Okay, the car stops at the petrol station. So state the period. Period means time. Period means time, okay. Obviously, in minutes, they already told you, right? State the period in minutes. The car at the petrol station. That means, in other words, they're asking you how long the car stops. How much time the car stops at this petrol station. So go back to the car. Green color motion graph is car. Okay. So you look which part of it is where the car doesn't move. Obviously, from O to P, distance increasing. So here P to Q, right? The distance doesn't change, so this part must be where the car stops for the petrol station. So the question is saying, how long did the car stop? From time 10 to time 12.5, just now we found. So how long does it stop? The answer is 2.5 seconds. 10 minus. Actually, let me do the working as well. Let me not skip steps. Very particular on this. Okay, because guys, we don't know how they decide to give you the marks, so better write everything. So let me do this. 12.5 seconds minus 10 seconds. Okay, so the answer is 2.5. That means the car stops for 2.5 seconds. Oh no. Hey, nobody correct me. Walao. 2 minutes lah. Yeah, minutes. That's why I say petrol 2.5 seconds can refill the petrol, man. Okay, 2.5 minutes lah. This makes much more sense. Okay, done. Okay. Okay, part C. Calculate the difference of the average speed. Okay, average speed formula come out. Average speed just now we show you formula given right? Average speed is you need to find the total distance divided by the total time it takes. So find the average speed between the bus and the car. Okay, that means this one you have to do one by one. Okay, so part C, you need to find the average speed for the bus first. Okay, so simply up to you for the bus first. Okay, so ask yourself the formula says total distance divided by total time. Okay, so ask yourself now. Focus on the graph for the bus. Okay, bus, the total distance that the bus travels from 40 travels all the way to 0. That means the bus must have traveled 40 kilometer just now you say already, right? 40 kilometer. So put here 40 kilometer. okay, divided by the total time. The time taken, how long did the bus take? Where? Bus, yellow color, took 25 minutes. Okay, 25 minutes. Okay, but hold up here, guys. This is where the question like to trick you. You look at this unit. What does this unit mean? In Malay, you see this one? I hope you can tell me what does this unit mean. This means kilometer per hour or kilometer per jam lah in Malay. Jam, okay? Hour in Malay is jam. So they want the answer in kilometer per hour. However, the graph give you in minutes. So have to change. The minutes you have to change to hour because the question wants it in kilometer per hour, not per minute. Very, very important. Make sure you check the unit of the question. Okay, so let me change this. I don't know if any of you saw this or not. So 25 minutes, we need to change to hour. Okay, 25 minutes. I hope you know how to change to hour. Okay, I prepare a small cheat sheet here. Okay, this one supposedly what from primary school, I think. Okay, hour change to minutes times 60. Minutes change to second times 60. Second change to minute divide 60. Minute change to hour divide 60. Don't know, you copy this down on the first page of your math paper. Before you start your math paper, SPM real math paper, you just write this down on the first page. Then only you start doing. Then you won't get scared. Okay, so now we are trying to change from minute to hours, right? So you have to divide 60. Let's go. Divide 60. This one you just press calculator lah. Okay, divide 60. Okay, did I write it here? Okay, okay lah. You go and calculate yourself lah. This one 25 divide 60 is a number, and then put the number here. Okay, so 40 kilometer divided by whatever that is. Okay, let me just do this. 25 divide 60. Okay, you're gonna get 0. It's an ugly number, but it's okay. 0.416666. You just put like this 7. Like that. Round up lah. This one I will put 5 to 6 decimal place to make sure it's very accurate. If you round up, some students they say, I just round up to 0.4 hours teacher. I say cannot This one you round up too much already. Don't. Okay. Put more. At least 5 decimal place. 6. Okay. Hour. Okay, so this one, you press calculator. I think 40 divided by this, I think you're going to get 96 kilometer per hour. This is for bus. Okay? So let me do the same thing for average speed for car. Because they want us to find the difference, right? So we need to do for both. So for car, the total distance, I think is the same. Right? Also 40 kilometer. Yep. But car uses 30 minutes. See? So car from 0 travels to 40. Yeah, also travel 40 kilometer, but car uses 30 minutes. Now, some students say, but teacher, the car got stopped. The car got stopped for 2.5 minutes, right? Do we need to count that? I say yes. Yes, even the portion that the car didn't move also need to count as the total time. So don't need to bother. Just straight away look at the last number where the car finally complete the journey. 30 minutes. 30 minutes. So you take that. Okay. So 30 minutes put here. But then again, this one have to change to hour, right? So 30 minutes change to hour. This one easier lah, yo. Half an hour lor. Okay. So half an hour just 0.5 lah. 0.5 hour. Okay. This one press calculator. You will get 80 kilometer per hour. Okay. So if the question is asking for difference, okay, difference between the average speed, that means take this minus. Okay, the word difference means minus in mathematics. Okay, 96, 90, so 16 kilometer per hour. Done. That's the answer. Okay. Okay. Okay, lastly, if OP, okay, let me zoom in. Okay, actually, you know what? Let me make this part smaller. Then I have more space to write. Okay, done. Okay, last part here, part D. Okay, part D says what? If OP is a highway route, okay, so where's OP? Okay, OP is right here. This first portion of for the car, okay, OP. This, so that means the car is moving in the highway, okay, driving on a highway. Does the car complies with the speed limit? Okay, this one, you guys, a bit of general knowledge. Speed limit, 110. Malaysia speed limit, highway, 110. Okay, so that means the question is asking, A, is the car for sure is moving, but is the car moving at the speed less than 110? If it's more than 110, that means this car is over speed limit already. So in other words, right, the question is asking for speed. The question is actually asking for what is the speed for this portion when the car is traveling from O to P. Okay, so if you guys recall, this is a distance time graph. How do we find speed? Here, from distance time graph, how do you find speed? You need to find gradient again. Gradient again. That means you are supposed to find the gradient from O to P. Okay? Find the gradient between O to P. So, same old, same old. Okay, same old, same old. From O to P, 2 points, right? O, of course, the coordinate is 0, 0. P, the coordinate is 10 and 20. Okay? X coordinate 10, Y coordinate 20. Okay? So, x1, y1, x2, y2, sub into the formula, the gradient is y2 minus y1, 20 minus 0, x2 minus x1, 10 minus 0, which is 20 over 10, 2. Okay. Oh, wait. Nobody remind me again. I did something wrong again. Why? Because unit. Because I said 2. Cannot be so big difference. 2. Because I forgot the unit. The unit is kilometer per hour, but this one is again in minutes. So this one here, the 10 minus 0, right? Let me write it nicely. Okay. The 10 minus 0 is actually in terms of minutes leh. Okay, so this one 20 kilometer. This one is 10 minutes. So 10 minutes I have to change again. 10 minutes I have to change to hours divided by 60. So 1 over 6 hour lah. Okay, so that means you do 20 kilometer divided by, instead of 10 minutes, you write 1 over 6 hour. Press this in calculator, you will get 120 kilometer per hour. Makes much more sense. Okay, so now you can answer the question, does the car comply to the speed limit? More than 110 kilometer per hour already. So the answer is no, it does not. That means must get ticket already. This one, speed ticket. Okay, done. Okay. Wow, 9 o'clock already. Wow. One question takes so long. No lah, because I go very detailed. Every single step I explain. That's why. But I think as long as you guys are learning lah, I think that's the most important thing. Fast, slow, that one secondary. If I go super fast but nobody can understand what I'm saying, then what's the point? Okay? Okay. So that's it for this question. Okay, I move on. Let me do one more question. Let me do one more question for speed time graph, and then this one I think we skip. Then we'll move on to the linear inequality. Okay? Okay, so let's read this question. Just now we did a distance time graph question already, so now we do speed time graph question. Okay, show speed time graph. Then okay, so this is a table that shows the speed at different time. That means when time is 0, the speed of this particle is 0. When time is after 2 seconds, the speed of the particle from 0 now it became 15 more. Okay, then at 6 seconds, the speed looks like doesn't change. It stays at 15, and then when it goes to 10 seconds, the speed looks like it increased double again, become 30. Okay, so that means looks like this particle is like moving from 0 to 15. This one accelerates, we say pecutan, right? Increasing the speed for 2 seconds and then stay consistent. The speed doesn't change, right? From 2 to 6, and then speed up again, pecutan again. This one acceleration again from 6 to 10 seconds. Okay, the speed increase again to 30. So based on this table, draw the speed time graph. Yeah, easy peasy. Okay, let's go draw. This one, guys, don't have to worry. Wait, how come this one cannot? Wait. Okay. Okay, so let me do here. Here. My speed time graph. Can I move this? I can't. Okay, never mind. So, very easy only. Mark. When time is 0 just now, the speed is 0, so here. Okay. When time is 2, right? When time is 2, the speed become 15. So when time is 2, speed become 15 right here. Wait. Okay. Right? And then when time is 6, it stays at 15. 6 stays at 15. Okay. When it's at 10, goes to 30. So mark only lah. This one, free mark question. Easy. Okay. Don't forget, must connect lah. Why? This app is such a fantastic app, but cannot draw lines properly. I was trying to, you see? Okay, never mind. Okay, and then here. Higher. Okay lah, I gave up seriously. You guys understood lah. Supposed to be a straight line lah. Use ruler lah. Oh yeah, one more thing just to remind you guys when you are doing your SPM paper, okay, regardless whether it's maths, maths, your sciences, okay, whenever you are drawing, please use pencil, please. Okay, don't go and use pen okay, but writing of course use pen lah, no need to say. Okay, but when you draw graphs like this, please use pencil. Why? Some students want to ask why. I love people who ask why because I like challenge. No lah, but it's good to ask why. Why? Because easy to erase in case you draw anything wrong, then easy to erase that was the reason. Okay, done graph done. Okay, so part B, based on the graph. Okay, so as you see that means all other question is gonna be based on the graph already. Okay, can, no problem. Based on the graph drawn, state the uniform speed laju seragam. Okay, state the uniform speed. That means they are asking what is the speed that the particle is traveling, and the speed is constant one. Okay. Let me write down. Remember, people who wow, you spell wrong, not uniform speed, uniform speed. Oh my god, let me zoom in. Uniform speed. So another name for uniform speed is constant speed lah. They mean the same thing. That means the speed doesn't change. So you look back to the graph at which part the speed doesn't change, at which part the speed doesn't change, this part lah, right? So the answer is just 15. Hey, please don't tell me 2 seconds, 4 seconds, 6 seconds. No, they are not asking for time. They're asking for the speed itself. Right? See? They're asking for the speed itself. So the answer is the speed. You must answer the speed, which is 15 meter per second. Done. Okay, next. Find the duration of time in seconds. Okay, see? Be careful of the unit. But this graph is good to you because I think the axis, the time axis is already in terms of seconds. Already in terms of seconds. Good. That means we get the answer from the graph. Can straight away answer this question. No need to change the unit. Find the duration of the time the particle is moving at the uniform speed. Okay, now only they're asking for time. So the portion of the uniform speed is obviously from here to here lah. Aiyo. Pardon my writing. Okay, this part, uniform speed. Okay, actually, Uniform or constant ah. Uniform and constant mean the same thing. Okay, uniform speed. So they say how long lah? How long does it use to travel uniform speed? That means from 2 seconds to 6 seconds lah. Okay, so 6 seconds minus 2 seconds. So the duration is 4 seconds. Duration means how long? Okay, done. That's the answer. Okay, next. Part C. So this one we done already. Calculate the rate of change of speed. Some students, what is this? What is rate of change of speed? Talked to you before, right? I told you all the information is on this single slide. Rate of change of speed. In another word, acceleration. The question wants you to find acceleration. So the question gave you speed time graph, right? How to find acceleration from speed time graph? You want to find acceleration? You do gradient again. Okay, let's go. Do gradient. Okay, so let me write this down. Acceleration of speed, in other words, is acceleration. They could have just said find the acceleration, but they try to trick you only. So calculate the acceleration for the last 4 seconds. Okay, that means where's the last 4 seconds? Last 4 seconds. Okay, last 4 seconds means from here, from the 6 to 10 seconds. This is the last 4, from 6 to 10, last 4 seconds. That means they want you to find the acceleration for this part. Acceleration for this part. Okay, part C. Okay, so we already know acceleration, how to find gradient, right? Just now we said. So gradient formula again, y2 minus y1 over x2 minus x1. So same thing. You need 2 points. Coordinate, write that down. 10 and 30. Okay, this one, 6 and 15. Okay. Then of course label x. Okay lah, I put here x1, y1, x2, y2. Then sub. Okay, sub equal. Bing. Y2 minus y1, 30 minus 15. X2 minus x1, 10 minus 6. Okay, so 15 over 4. This one might as well just press, just change it into what do you call it? Decimals. Okay, change it to decimals. So the answer is did I do where is it? Yeah, 3.75. Since this is acceleration, okay, so the unit for acceleration is meter. This one is meter per second. So meter per second square. Okay. Again, if you don't know, you just memorize for now. Don't have time to explain why is it that way. Okay, but anyways, they also write it here for you lah. Okay, so don't worry lah. They also gave you the units here lah. Yeah. So the answer for acceleration here, we found the gradient, which is 3.75 meter per square second. Done. Okay. Lastly, calculate the average speed. Okay. So again, average speed formula is total distance over total time. Okay, total distance over total time. So the average speed of what? In the period of 10 seconds. That means 10 seconds, that means, okay. That means they want the average speed of the entire journey because the entire journey of this particular really takes 10 seconds. So, okay, first thing first, I can already say the total time for sure is 10 seconds. Okay, now I need to find what is the total distance that is traveled within the 10 seconds. Hey, some student, they go and pandai, they put, teacher 30, the answer is 30. No, hello, this one is speed time graph. This is not 30 meter, this is 30 meter per second, this is speed. Okay, so reminder, given speed time graph, you want to find distance. Coming back to my little diagram over here, from a speed time graph, you want to find distance. What to do? You need to find the area under the graph, which is this portion. So let me go back. That means we need to find this area. From 0 all the way to 10, right? Okay. Everything below the graph. Everything below the graph. You need to find this area. Okay. So some students, you teacher, what shape is this? So very hard to find the area. I said, one step at a time lah. Don't have to rush. One step at a time. So for those who can see, actually, this one is actually two, if you can see, right? This is actually two trapezium. You see, the first trapezium is here. This one, this one, this one, and this one, right? The first trapezium. The second trapezium is here. This one, this one, this one, and this one, right? So if you find the area of these two trapezium, I call this number 1 and number 2 lah. Okay? If you find the two area of trapezium, all you need to do is just add them up lah. Then you will get the total distance already. Okay, so let me write it here. Total distance is the area from number 1 add with the area number 2. Both are trapezium. Okay, so if you recall just now, okay, the formula for area of trapezium, let me write it down. Actually, I need to zoom in here. Okay, easier to write. Okay, so area of trapezium. Okay, half times A plus B. The A and B is the parallel sides lah. Okay, times the height. Okay, so the first area, area number 1. Okay, now the first area is like this. Okay, let me draw out the shape. Actually, let me draw out like this. This is the first area, the first piece, not the first area, sorry. Okay, so let's label. First of all, this is the A and the B lah. So the A looks like it's here. So how long is this? This is from 2 to 6. You see this A? This is from 2 horizontally to 6. So that means this must be equals to 4 lah. The unit 4 unit 1, 2, 3, 4 units. Okay. Then B. This is from 0 to 6. So the length here is 6. Okay. And then lastly, we need the height. So the height is from here down. Okay, from here down. Okay, how many? From 0 to 15, right? You see the height from 0 to 15, Okay, so the height here, height is 15, okay? So with that, now you can sub in already, half times A plus B, which is 4 plus 6, times the height, which is 15, okay? This one, press whole thing to calculator. I don't know what it is lah. You press lah. Okay? Do the same thing for area number 2. So area, okay, this one you see, this trapezium is like it's like from a horizontal trapezium. I put it vertically. I put it vertically. Okay, so let me draw here. Okay, so the trapezium become like this. Hey, like that. Okay, so that means my A and B is here, guys. Hello, A and B is here, please, because A and B is the parallel sides. Okay, so for this case, my A is gonna be the vertical length already, which is, for this case, 15. From 0 to 15, then 15. Okay, 15. And then my B from 0 to 30. 30. Okay, and then the height is gonna be here, which is from 6 to 10. 4 lah. Okay, so sub again, half times 15 plus 30 times 4. Okay, and then this one, you go and press calculator to get the value. Anyways, once you press calculator for area 1 and area 2, right? And then you add them up lah. All right, to get to the total area. Total area is the total distance lah. From my previous working, the total distance I actually get 165. These two value add up. You should get 165 meter. Okay, why meter? Because here lah, then the speed is meter per second. So meter, the distance must be meter. Okay, over 10 seconds. So press calculator. This one no need press calculator also can. Okay, done. 16.5 meter per second. Okay, so as you can see, these two questions actually already cover everything you need to know for graph motion, graph gerakan or graph of motion. Okay, everything else, actually this question just reuse the knowledge only. Okay, okay, give me one second. I drink 2 sips of water, and then we will start. We will do the next chapter. Okay. Yeah, I hope you already took a picture or whatever. Okay, let's move on. This one. Okay, bear with me. 45 minutes left. There's not much time also. Intensive lah, intensive. Okay, very fast one. Okay, linear inequality, right? There are only two types of question. The question will ask. Okay, two types of question. The first type of question, right? The question will give you given the shaded region. Something like this. Actually, okay, shaded region. And then they give you shaded region, and then they ask for the inequality equation. They will ask for inequalities. That means your answer must be in inequalities. Later, I will, of course, do an example question. Okay. Another type of question is swap. They give you the inequality, then they ask you to shade. It's like flip around. So you need to know how to do back and forth. They give you area, they give you the shaded region. You need to know how to get the inequality. Or they give you inequality, you need to know where to shade. Back and forth. Okay, two types only. Two types of question. Okay, so let's start. Okay, this question obviously is the first type of question that I mentioned. Okay, this is, let me just write it down here. This one, type 1 question. Okay. Type 1, type number 2. Okay, so let's do a type 1 question here. I don't know how you guys learn this in school. Okay, I know a lot of students, they find it very confusing. Is it more than or is it less than, right? I never get confused because let me show you how I do it. Okay, obviously, so they gave you this region. They said write 4 inequalities. That means my answer, I must have 4 answers. 1, 2, 3, 4 equations. Okay, inequalities. In Malay, inequalities is called this, ketaksamaan. Okay, but I tell you, every time you see this shaded region, you know already for sure they're asking for this inequality. You know already one. Okay, that defines the shaded region. Okay, so first step, must always write down the equations. Oh my god, equations of all the lines that covers up the region. For example, in this diagram, right, this is the shaded region. I think it's pretty obvious that you can see this shaded region got 4 sides. 1, okay, oh, another color. 1, dotted one, this is the first line, right? 2, this is, oh my god, this is the second line. Okay, 3, there's a reason why I change color. There's a reason why I change color. Okay, the reason I change color is because I hope some of you will be able to tell me why. Green color is dotted line. You see? Okay. Then I change color blue because this one is solid line. Okay, so you see here, looks like they really use 4 lines to form this region. Okay, let me label line number 1, line number 2, line number 3, this slanted one, and line number 4, this horizontal one. Okay, so the first step is to write down the equation of all of these lines. Now, writing the equation down, we already did this. That is why, guys, do you realize that I teach you the first ever lesson, I teach you straight line first? Because all of this chapter, graph of motion, linear inequality, they all need the understanding from straight line. From straight line, the y equals to mx plus c thing. Okay? So, let's do one by one. Okay. This first line, horizontal line. If you guys recall, horizontal line, what is the equation of a horizontal line? I hope you can tell me. This horizontal line cuts the y-axis. Oh yeah, how come I never label x and y? Okay, cuts the y-axis at 8. So the first equation is y equals to 8. Done. This is how the equation of a horizontal line always look like. Horizontal line always y equals to where it cuts. Vertical line, okay, right? Number 2 is a vertical line. It cuts at x-axis -12. So x equals to -12. This is how you write the equation of a vertical line. This is just a little bit of revision. We did this in our first class. Okay. Third line. Okay. Third line is slanted already. Slanted. Okay. Third line. Okay. Slanted line. No other option. Third line. Okay. You have to do the y equals to mx of c. If not, you cannot find the equation. Okay. So I have to do old style lah. The m here is gradient. So gradient of course need 2 points. Here we have 2 points. Okay, so write down the coordinate of these 2 points. This one is x coordinate 0, y coordinate 8. This one x coordinate -8, y coordinate 0. So this 8 here, isn't it not the y-intercept? If you guys recall, c is actually the y-intercept one. So actually this one, yay, no need to do anything. Straight away we can read out from the graph is 8 because it's the y-intercept. The c value means the y-intercept of the line. Okay, so that's good. That means we got the equation of this line already. It is y equals to 1x, but 1x nobody write 1x one, just x. Okay, x plus our c, which is 8. Done. This is the equation of the third line. Okay, and then the last line here, number 4. Again, you see number 4 is also a horizontal line. In fact, this line is actually the x-axis itself, right? So yeah, don't worry. If it's horizontal line, again, ask yourself, this line cuts where? Cuts the y-axis at 0, right? This horizontal line cuts the y-axis at 0. So the formula equation y equals to 0. Done. Okay, this is the first step to write down all the equation of the lines that is boundary, that is setting the boundary for the region 1, 2, 3, 4 for this case. Okay, done. After that, this is where some student will get confused. Really, teacher, is it more than or is it less than? Right? Figure out the inequality, guys. Here is my trick. This one, no one teach me one, really. This one I somehow, that time I was in my university, okay, studying for university, just suddenly could have done that, because in university we also need to do a little bit of this one. I said, could have done that, nobody teach me. And then it worked all the time. And then it's so easy. But I don't know why nobody teach me. So I show you, okay. Where is it? Okay. How do you know whether is it more than or is it less than, right? All you need to do is pick any point in the region, okay? Because anyways, they want the inequality that define the region, the shaded region. So you choose any point that you want. So let's just say I choose a point somewhere here. So what is the possible coordinate here? Maybe it's -8. Okay, maybe it's -8, and definitely not 8 lah. Definitely less than 8 lah. Maybe I don't know 6 or something. Yeah. So -8 and 6 definitely is a point that is in a region, right? I'm gonna sub this point, -8 and 6, into all my equations, and then I see what happened. Okay? You guys see, magic, very easy one, I tell you. Okay, I sub one by one. Okay, -8 is x value, y is 6 is y value. Okay, so when you sub, you see how you sub. Okay, number 1, y is what? 6, right? Okay, so 6 sub in here. 6. Don't write the equal sign first. You put, and then the other side is 8, so copy 8. Now you ask yourself, is 6 more than 8 or less than 8? Obviously, less than, right? Right? The mouth like this, right? Smaller mouth to the 6, bigger mouth to the 8, less than, right? So that means all you need to do is, for the first equation, change the equal sign to this sign. That's the answer. Y less than 8. Done. You no need to think, you on the left side is more than or less than, later on the right side is more than or less than, like that. Very hard, right? Very confusing. No need. My way, just really take a point, you sub into the equation, and then you check the sign. Is it more than or less than? Then you just copy the sign and replace the equal sign. Like that only. Okay. Now, this is where the dotted line and the solid line plays a part. You see, line number 1, green, dotted line. So dotted line means you leave it this way. Do not put an equal sign. If later for 3 and 4, you need to put the equal sign already because it's a solid line. This one, 1 and 2, not solid line, dotted line. So just leave it like this. Okay? Come, let's do the magic again for number 2. Okay, so I can use the same point because it's the same point. So the same point is within the region. So I use the same point. X is what? -8, right? Okay, I sub in -8. Don't write the equal sign. Copy the other side. Okay. Now you ask yourself, which side is bigger? Okay, obviously, -8 is bigger than -12, right? Okay, done. That means you need to take this sign. X and -12. Replace the equal sign with the sign that you see. Like that. Done. Okay. I hope this technique helps you because it helped a lot of my students. No need to memorize one. Just pick a point in the region and sub. Okay. Y 6. Okay. Don't put equal sign. X -8. -8 plus 8. -8 plus 8. This one is equals to 0. So ask yourself, 6 and 0, which one bigger? Obviously 6 lah. So like that lah. So like that done. Okay, just change the equal sign to this side. But remember, solid line. So must put one more line. That's it. Okay. Last one. Y, what is Y? 6, Okay, 6. Don't put equal sign. The other side is 0. Same thing again, It's like that, Okay, so that means we have to take this one. Y more than 0. Is it solid line? Yes. So put another line. Done. These are my answers. And this is type 1 question. They give you a shaded region and they ask for inequality. That means your answer must be like this. Okay, easy peasy. Okay. Okay, So take a picture of this first. We only have 30 minutes left. Okay. Let me I think we can do 2 more questions only lah. Yeah. I'm gonna do one question for type 2. Okay? Okay, done. Take picture already. Bye. This one is the same question. This one. Yes. This is type 2 question. Where you realize here, they didn't shade the region for you already. In fact, they asked you to shade. They asked you to shade, but they gave you the equations. They gave you the equation and then they asked you to shade. Just now is they shade and then they ask you to give the equation. Okay, so this one is type 2 question. Okay? So, okay, so let's start. Okay. In order to, okay, what to say? Okay. Satisfy 3 inequalities. Oh, okay. Actually, they are quite good to you, guys, because of 3 inequality. This is number 1. Okay, actually, let me just write it nicely here. Okay, let me just write nicely here. Number 1, y more than or equal to -x. Number 2, y less than or equal to 6 minus 2x. Okay. Number 3, y less than 6. Less than 6. Okay. So, obviously, if you want to shade a region, you think logically, if you want to shade region, you must draw the boundary first, right? So without the boundary, you cannot shade because you don't know where is the the lines, right? So the first step number 1, okay, for this type of question, you must always draw the lines out first. Okay, you must draw the line out first. So I want you to compare type 1 and type 2 question. remember when we do type 1 question, we came up with the equation of the line first, right? We highlight the boundaries and we came up with the equation of the line. But for type 2 question, they gave you the equation. Now you have to draw the equations out. You need to draw the equations out, draw the line out, okay? Now you see how they draw the line out. Actually, they are quite good to you. Because you see here, y equals to negative x. This one is for this line what? It's for this line what? They already draw it for you. This one they done for you already, right? The other line, y equals to 6 minus 2x. This one lah. They already done with for you already. So you see, they're very good to you. They draw 2 boundaries for you already. Okay? So all you need to do now is draw the last line. So when you want to draw a line, right, having this inequality sign won't help you. So in order to draw a line, you just temporarily change the sign into equal, like that. Then easy to draw lah. Draw this line. Okay, draw this line. So recall, how does this line work? If you see the equation is like y equals to a number, x equals to a number, you know for sure it's going to be either vertical line or horizontal line. Okay, then this one you ask yourself, okay, what is a line that cuts the y-axis at 6? Y-axis cut the y-axis at 6. Oh, by the way, I just want to point out, right? You see this line here, y equals to 6 minus 2x. Actually, I can rearrange this to make it like y equals to negative 2x plus 6, right? These two, I can swap place. Why I want to swap place? Because if I swap the place, this is like y equals to mx plus c1, right? It's going to be in the same format already. Okay, once I swap the place, the format will be y equals to mx plus c. Then if you realize that the c, if you compare, c is 6, right? C is 6. That means the y-intercept for this line, okay, is 6. That is what it means. Okay, so you see the third line, y equals to 6 so if you want the line to cut y-axis at 6, that means it must be horizontal line, lor. So cut at 6, that means it must be cut here, lor. There. Done. Okay. Can I move up a bit? Cannot. Okay, now I good enough lah. Okay, you guys get the point lah. Okay, so there. Never mind. Okay, I was trying to be OCD. Okay, done. So let me label this here. This line here, y equals to 6. Done. Okay, I got my third line ready. Okay, so my first step done already. I got all my lines out. Now step number 2. Okay, if you guys recall just now, when I did the type 1 question, right? Step number 2, I told you, pick a coordinate, right? Pick a point in the shaded region, right? And then you try to sub into the equation. Here also same. You just pick, okay? Pick a point. Pick any point lah. Any point. So for me lah, I pick a point here lah. Pick a point here lah. Okay, I pick a point here. So what could be a coordinate for this point? Maybe the x coordinate is 0, definitely is less. Y coordinate definitely is less than 6. So maybe 4, 3, whatever lah. Okay. You pick any point and then you sub again into all your equation. You see how the magic will work, all equation. Okay, so you see how I do it. Number 1, y and negative x, right? Y and negative x. It is supposed to be more than or equal, okay? So okay, y more than negative x, we are talking about this line right here. Actually, let me just highlight. This is the line that we are talking about. So the other 2 lines, ignore the other 2 lines. Ignore. I know we already draw it in, but ignore the other 2 lines. Just focus on this line because this is the first inequality we are doing. Okay, so take this point and sub into here. Sub into the first inequality. X is 0. Okay, wait. This one is x, this one is y. So y is 4. X is negative 0 means 0 lah. Okay, 0. Then ask yourself, does this make sense? 4 more than or equal to 0? Is this correct? Is this correct? Yes, this is correct. 4 is really more than 0, ma? Yes, it's correct. That means this point must be within the shaded region that is bounded by this line already. This point must be within the shaded region, because if it's not, then the sign would not make sense already. Okay, that means yes, later on we have to kind of shade this side so that you can make sure this point is within the shaded region. We have to shade here already. Okay, okay, okay. So done, let's move on to the second. Okay, let's move on to the second equation. Y less than or equal to 6 minus 2x. So same thing, take the same. Okay, so let's put our focus. We're done with number 1 already, right? Okay, erase. Let's put our focus on the second line. So our second line is this one. Okay, ignore the other 2 lines. Now let's put the focus on the second line here. Okay, this one here. Okay, this line here. So our 0, 4 is on the left side of this line. Okay, same thing. Sub x, y is 4. Okay, then this one is 6 minus 2. X is 0. Okay, so this one, 6 minus 2, so 6. Okay, so ask yourself, 4 and 6, does it fulfill the inequality? Yes, 4 is really less than 6 one. Yeah, 4 is really less than 6. It's correct. It's correct. So that means this point is within the shaded of the second line. That means must be here already. Must be this side. So that it's being shaded, must be on the left side. This is what we want. Like that. Okay. I think most of you maybe can see already where the shaded part is going to be, right? But it's all right. We have to do the whole thing. Okay, let's check the last one. Number 3. Number 3, okay, number 3. Y less than 6. Okay, so take y. Y value is 4. This is 6. Is it less than? Yes, it's less than. Yes, it's less than. So that means this one is the region that we want. Okay, this was the line that we are talking about, right? Okay, so the point is below the line. Yes, this is the region that we want because it fulfills the inequality. So that means shade bottom, shade bottom, bottom here. Okay, this is what we want. So if you can see, the only region that is being shaded by all 3 is right within here. And here inside. All right, this is the region that is being shaded by all 3. Okay, done. That's the answer. Oh, nobody remind me. Nobody remind me. I realize. We talked about just now about the solid line and dotted line. Solid line and dotted line. Nobody remind me. You see this last one? This one is without the equal sign. The first 2 got equal sign. You see? The first 2 got this equal sign, right? This extra line. But the third one doesn't have. The question said, you see the question? Didn't have it, right? That means my third line, I shouldn't draw a solid line. I should change it to dotted. Nobody remind me. Step. Wait. Can we? Oh, there's no way. Okay, never mind. Let me erase this and then I do manually. So like this, I'll do dotted. Okay, this one they will minus mark. Unfortunately, if you do solid line, okay, so this one must be dotted line. This one dotted. Okay, these first 2 solid, which they already drew it for you. Okay, done. Okay, great. So to summarize, that's it already. Okay, the last question I will want to do also, because this is a worded question. Okay, this is worded question. Okay, very, very common question also, so I will do it. But to summarize these 2 type of question, the 2 steps is very similar. The first one is about the lines. Okay, if they give you the region, you list down the lines. If they give you the lines, you draw in the line. Okay, so first step is always deal with the boundary first. Okay, and then the second step, you take a coordinate and you sub it in. Okay, and then you can check lah, the shaded region. Okay, done. Okay, last question. Okay, so let's read the question first. What do they say? Okay, cafeteria sells 2 types of noodle, J and K. Okay. So on a certain day, cafeteria sells X bowls of J noodle, Y bowls of K noodle. Okay, so for me, I prefer to write in a table form because too many information really very confusing. Okay, J noodle and K noodle. Okay, so cafeteria sold X bowls of J, Y bowls of K. Okay, can. A bowl of J noodle and a bowl of K noodle cost $8 and $4. So this one is $8 per bowl. Okay, this one here is $4 per bowl. Okay, done. So what do they say? The noodle sales in the day are based on the following. Okay, number 1, 2. So there are 3 key points here. 3 key points here. The number of favorite J noodles. Okay, the number of J noodles sold. That means here. That means X. Okay, X is at most. That means at most it cannot more than. Okay, can be less than but cannot more than. It's called at most. Okay, at most. That means can be less than but cannot more than. Can be equal also. So less than or equal. So at most means like this. Okay, twice the number of K noodle. So twice means times 2. 2 times the number of K noodle, which is Y. So 2x times 2y. This one is Y. This is Y. Okay, so this is our first linear inequality already. X less than 2y. Okay, number 2, the total sales number of the bowls cannot be no greater than 80 bowls. That means, right, the total, so we sell X bowls for J, Y bowls. The total means X plus Y. Okay, the total bowls you sell, right, cannot be greater. That means, again, can be less than, cannot be more than, like that, 80 bowls. So this one is the second equation. Okay, last one. The total sales on that day is at least 320 ringgit. So sales means money already. So you need to calculate. Okay. For J noodle, 1 bowl is $8. If you sell X bowls, that means multiply, right? X ringgit multiply by how many bowls you sell. So 8x. Okay, 8x. For K noodle, how much you sell? 4 times Y. Okay. Total means you add together. Total means add together. The total of the sale must be at least, means you can be more than, but you cannot less than. So at least means can more than, can equal, but cannot less than 330. Okay, this is your third equation. So you see, part A, write 3 inequalities. Tick, 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 okay, other than these 2 that represent the situation. So basically, it's these 3. 1, 2, 3. Okay, so obviously, this type of question, by using a scale of 2 centimeter to 10 units, that means you need to measure. This one obviously is online, so it's not going to be accurate. But in exam, you really need to measure. Like let's just say from here to here is 2 centimeter. 2 centimeter to 10 units means 0. 2 centimeter, this one 10. Another 2 centimeter, 20. Another 2 centimeter, 40. Like that. That's what they mean. Okay. Okay. Then they said, on both axes, draw and shade the region. So this is actually so it's like you have the equation, right? And then they want you to draw. It's kind of like a type 2 question, except the type 2 question, they already gave you the equation. This type of worded question, you have to come up with the equation by yourself. Okay, so let's do that very quickly. So 60, 80, 100, 120, 140, 160. Okay. Normally, horizontal axis is X lor. So X here means the number of bowls we sell for J noodle lah. Okay, so horizontal axis means this one is for J noodle. Okay, so do the same thing for y-axis. So y-axis must be for the number of bowls for K noodles. Okay. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, done. Label Y. This one is for K noodle. Okay. So, okay, now we can start to draw already. So again, first step, draw in the lines lah. Draw in the lines. So, this one, unfortunately, they didn't help you to draw. So you have to draw it yourself. I show you guys a very easy trick to draw lines. We all know that in order to draw a straight line, you just need 2 coordinates. You just need 2 points. So let's do it here. Okay, let's do it here. You just need 2 points. That means I show you one example, then you will know already. So the first equation, right, is x. Of course, it's equal lah. We want to draw the line first. Ignore the inequality first. Okay. So I say right? You need 2 points. That means two pairs of coordinates lah. So very easy only. You just sub lah. Okay. When x is 0, 0 equals to 2y. So you solve lah. That means y for this case has to be 0 also. No? So 0, 0 is 1 point on the line. Okay, and then another one, you see since our graph goes all the way until 160, right? Okay, maybe we do maybe until 100 or 100, yeah, 100 lah. Let me sub 100 into x. Okay, any point you like lah, but I usually use a point that is really in the graph lah. Okay, so 100 equals to 2y. So you solve 2, go the other side, divide. That means your y has to be 50. Done. See, 2 points ready. Right? So use these 2 points and plot it in the graph. 0, 0, and then 100, 50. 100 is here, 50 is right here. Done. Okay? So take your ruler, draw. So this one you need to be careful a bit when you draw. Do you need to draw a dotted line or solid line? Depends on the sign. This one got equal. Okay, so this one solid line. Okay. So this one, let me label x equals to 2y. Okay, and then the other one, do the same thing also. Yeah, I know lah. This topic is a bit boring in the sense because the working is very repetitive. Okay, but do it for yourself lor. So do the same thing lah. Okay, so this one, when you sub x as 0 plus y equals to 80, that means y is 80 for this case. Okay, this is my first point. Then sub x as 100 plus, hold up. So 100 plus y equals to 80. If you do this, you will get y equals to negative value. Cannot, okay, y definitely cannot be negative. So maybe 80 is 100 is not a good value to sub for x already for this case. Maybe we have to go definitely less than 80 lah. So maybe we go simply lah 60 . Okay. So just choose 60 because 60 is also in the grid. Okay, so 60 plus y equals to 80. That means y has to be 20. That. So 2 points, 0, 80. Then another point, 60, 20. Done. Okay, so another line. Wait. There. Nice. Okay, this one is my other. You also you guys notice when I draw the line, I draw it as long as possible. I don't draw it very short one. And it's important to draw, it's important to cover the whole graph with your line, huh? Okay. Okay, now the third one, number 3. Where is my equation? Okay, 8x plus 4y. Here. 8x plus 4y equals to 330, 320. Okay, so same thing lah. We do 0 and 60 lah. Okay, so sub x as 0, 4y equals to 330. So this one, you do calculation, it should be 80. And then another one is 60. So x is 60. Oh, cannot. I think too big already. Too big already. Okay, never mind. There's actually another trick lah. Some students, if they are smarter, right, they say, hey, teacher, can I sub y as 0 to get another point? Can. Why not? Right? Sub y as 0 and then solve for x lah. Can. Right? So this one becomes 0. 8x equals to, so 8x equals to 320. X equals to divide by 40. Can. Okay? So 2 points already here. 0. So 0, 80 is here. 40, 0 is right here. Okay, so let me do another line. There. Okay. Okay, this one is 8x plus 4y equals to 320. Done. Okay, done. There we go. Okay, we got our lines ready. Okay, now same thing, same. Test the region. Most probably, normally, it's gonna be either this one or this one normally is bounded right? Normally So for me, I think I'm gonna go with this Okay, I'm gonna go with this region. So choose any point. I'm just gonna choose a value that I can sub in easier. Okay, I'm gonna choose this point here. 20 and 40. 20 and 40. So this point, 20, 40. Okay, so we sub one by one. Okay, so I choose another color lah. Okay, so this is x value, this is y value. So 20 and then 2 times y, 2 times 40, which is 80. Ask yourself, is this correct? Yes, 20 is really less than or equal to 80. Yes, it's correct. So remember our first line was here, right? This one is our first line. So that means this is the region that we want. Right, this point is above the first line, right? So that means this is the region that we want. Above this one we want because it's correct. Okay, next, let's sub x is 20, y is 40. 20 plus 40, 60. 60, is it less than 80? Yes, it's less than 80. So our second line is where? Our second line is this one right here. This one right here, and then this point is on the left side. Yes, right? We want this point. It's correct, right? So that means must shade on the left side of the second line. This is what we want. Okay, lastly, double check. X is 20, so y is 40. 8 times 20, 160. This one, 160 also. So 160, 160, 320. So 320, is it more than or equal to 320? Yes. Equal? Got this line? 320 equal to 320. Yes, this is correct. So that means the third line is this one over here. The point is on the right side. It's on the right side of the line. Yes, this is what we want. That means we have to shade here, here, here. All right. So looks like the only region that gets shaded by all 3 lines is here. We guessed it correctly. Normally it's bounded by the 3 lines one. Here. Okay, done. This is the region. Okay. Okay, so done. Long question this one. Okay, finally. Wow, just nice. 3 minutes left. Using this graph, find the maximum and minimum number of bowls of flavored K noodle. So the bowls of flavored K is y basically. So in other words, right, they want you to find the maximum y and the minimum y. Okay, if the number of bowls of favorite J noodle, okay, that means if x on that day is 40. So that means, right, they want you to use the graph and find when x is 40, right? J noodle is x, so x is 40 here. Okay, here. X is 40. The shaded region is the green color region. So you need to see at 40, at x is 40, what is the smallest and the biggest y value you can ever get? So obviously, the smallest value is here. This one is your smallest minimum y value. Then until here only, your maximum y value cannot go more than that already, because the shaded region is bounded here. Okay, so if you read the value, the values are actually what? Yeah, actually I use this one better. The values, the maximum values is between 30 and 40, so 35. This one minimum between 20 and 30, so 25. So minimum is 25 bowls, and then maximum is 35 bowls. Okay. Nice. Wow, 1 minute left. Thank you so much, guys, for staying with me. Yeah, I know it's not easy lah. Thank yourself also. Give yourself a pat on your back lah. Okay. Okay, that's it. If you don't have any questions, we'll continue. We'll definitely do 2 more new chapters tomorrow. Okay. Tomorrow the chapter is going to be graph. How to draw a graph and solve question with the graph, and quadratics. Quadratics is something square plus something like quadratics tomorrow. Okay. Okay, so if you don't have any question, you may leave ready. Okay, good night, have a good sleep, have a good rest. Okay, you can leave first, no problem. I'm gonna ask a question. Can ask in the previous question. So the highway speed limit. Yes. Go back to here. Here. Yes. Okay. Oh, good question. Good question. Actually, it's a basic knowledge. Yes. I know. It's like, I know. So that's why I say you do the trial paper. You do the trial paper. This question, honestly, it came from trial paper. When I see this question, actually, I was so shocked, because I was like, hey, the question really didn't give, the question really didn't give the speed limit. They expect you to know. Okay, it's okay. Okay. Any other question? Okay. So no more question. Then I'm gonna stop the recording here, and then I'll close the session already lah. Okay lah. Good night, guys.